Hi guys, welcome back to my channel Ace Education. How are you guys? What's going on? You know, I've already started one video on the concentration, and let's continue some numerical question based on the concentration term. Look at this question. I'm going to read the question. A solution of sodium hydroxide had a concentration of 4 gram dm cube. What is its concentration in mole per dm cube? It's just a conversion factor. We will do how to convert mole dm per cube to gram dm per cube. Okay, look at this formula. You can see my previous video to figure out this formula. Conc equals to concentration equals to mole over volume. Okay, mole in terms of the mass. Mole is nothing but mass over its mr. So plug the same mass over mr here. So conc equals to mass divided by mr, which is mole, 1 over vol. Okay, is that okay? Yeah. So bring that mr to that side. So conc time mr equals to mass divided by volume. How you measure the mass? Mass is measured in terms of gram. Okay, gram. How you measure volume? Dm cube. So bring that dm cube to that side. It's become gram dm minus 3. So to convert mole dm cube to gram dm cube, we have to multiply conc by its mr. So conc time, that's a short formula, conc time mr equals to gram dm minus 3. What's the given in that question? You have gram per dm cube and you have to convert into mole per dm cube. So in that case, you have to divide this. Conc equals to gram dm minus 3 divided by its mr. What's the conc in terms of gram dm cube given? 4 divided by mr of sodium hydroxide. Mr of sodium hydroxide, NaOH, sodium 23 plus oxygen 16 plus H1, which is nothing but 40. So 4 divided by 40 is equals to 0.1 gram mole per dm cube. We will do one more question. Is that okay? Is that clear? Can I rub that question, guys? Look at this question. What is the concentration of a 0.05 mole dm minus 3 solution of sodium carbonate in gram per dm cube? So in that question, conc is given in terms of mole per dm cube, and we have to change into gram per dm cube. So look at the board. I have given this formula. Conc time mr equals to gram per dm cube. This time we have to convert mole per dm cube into gram per dm cube. See, look. Conc time mr equals to gram per dm cube. What's the concentration? 0.05 of sodium carbonate. Can anyone let me know what's the formula of sodium carbonate? Okay. Na2CO3, sodium carbonate. If you don't know the formula, don't worry, I will teach you. Sodium 23 times 2 plus carbon 12 plus oxygen 16 times 3. Use your calculator and work out. This is 106 So 5 times 106 divided by 100. How much is 5 times 106? 106 times 5, 35. Look at that. 106 times 5, 530. So 530 divided by 100, I think 5.3 mole per dm cube. Is that okay? Yeah, we will do one more question. So you can change anything from mole dm cube to gram dm cube. The conversion factor is that conc into mr equals to gram per dm cube. Okay. Okay. Look at this question. In that question, we have to work out the volume of the sulfuric acid. Now, what is the maximum volume of 0.5 mole dm minus 3 sulfuric acid needed to react with 0.24 gram of magnesium? It's a kind of stoichiometry and the concentration question. They clubbed both together. Whenever we have a stoichiometric type of question, you have to write its balanced chemical equation. So magnesium reacts with sulfuric acid to form what? Any idea? Any guessing? Metal react with acid to form salt plus hydrogen gas coming off. So magnesium, Mg, react with sulfuric acid to form magnesium sulfate. Don't worry guys, keep on telling you. Don't worry about the formula of magnesium sulfate. I will teach you in my future videos. So Mg, for time being, look at the question. MgSO4 plus H2 gas. So what is the maximum volume of sulfuric acid? We have to focus only on these two reactants. I don't want the product. With the help of all these quantity, you can figure out the mole of magnesium. Look at the mass of magnesium given. Use the formula to work out the mole of magnesium. Mole equals to mass by its AR. So 0.24 divided by 24, which is nothing but 0.01 mole. So 1 magnesium, 1 mole of sulfuric acid. Look at the theoretical molar ratio. That's 1:1, guys. Look, 1 element of magnesium, 1 mole of magnesium element react with 1 mole of sulfuric acid. Look at 1:1 ratio, molar ratio. And with this gram, we just work out the mole of the magnesium. 0.01 mole, we got it from that. So which is also equals to 0.01 mole of H2SO4. So we got the mole. Now we have to figure out its volume by using concentration formula. Conc equals to mole over volume. Do we have a concentration? Yes. Do we have a mole? Yes, mole of the sulfuric acid. And we have to work out the volume, rearrange it. So volume equals to mole over its conc. What's the mole? Just now we got it. Mole equals to 0.01 and conc equals to 0.5. So it's 1, this 0, 1, 0, 1, 0 cancel. 0.1 divided by 5, or 1/5 times 10 to the power of minus 1. 1/5 is 0.2. 0.2 into 10 to the power of minus 1, or 2 into 10 to the power of minus 2. Guys, I'm really sorry. I have a habit of doing this type of calculation. Don't get confused with that. You can use your calculator to figure out the answer. Okay, let's do one more question. Look at one more question, and it's a type of stoichiometry and concentration based. What mass of barium sulfate would be produced by adding excess barium chloride to 20 centimeter cube of copper sulfate of a concentration 0.1 mole? Okay, whenever I just told you this type of question is given, we have to write its balanced chemical equation. So barium chloride react with copper sulfate to form barium sulfate plus copper chloride. We don't need copper chloride, CuCl2. Is that okay? So what mass of barium sulfate would be formed? So we have to work out the mass of barium sulfate. Look at the molar ratio: 1 mole, 1 mole, 1 mole, 1 mole. And what is provided in that question? We have 20 centimeter cube of barium chloride. So conc of barium chloride is given, which is 0.1, and mole of barium chloride is given, which is 20 centimeter cube. So guys, whenever we have a conc and a volume, the best thing is that you have to work on number of moles of barium chloride. So N equals to C times V over 1000. How much is the conc? 0.1. 0.1 times 20 divided by 1000. So this cancel. So 2 into 10 to the power of minus 3. Is that okay? So that's the mole of barium chloride. What's the molar ratio of barium chloride and barium sulfate? 1:1. What mass of barium sulfate would be provided by adding excess of barium chloride? My bad, guys. That's the barium chloride in excess. So this is the volume. What mass of this is the volume and concentration of copper sulfate, not the barium chloride. Look at that. Barium chloride is in excess. So that says in excess. 20 centimeter cube of copper sulfate and a concentration of copper sulfate is given. So I'm writing here CuSO4 number of moles equals to 2 into 10 to the power of minus 3. How? C times V divided by 1000. Conc of copper sulfate is given, volume of copper sulfate is given. So that's the number of moles. So we have to look at the relationship between copper sulfate and barium sulfate. What's the molar ratio? 1:1. Okay. So moles of BaSO4 form is 2 into 10 to the power of minus 3. Is that clear? With that mole, can we work out the mass of the barium sulfate form? Yes, we can. So mole equals to mass over its volume, or mole. Why volume? Mole equals to mass over its MR of barium sulfate. Now rearrange this formula to get the mass. Mass equals to mole times its MR. What mole you got it? 2 into 10 to the power of minus 3. When you work out the MR of the barium, you will get 230 33. So, which is 466 into 10 to the power of minus 3, or 0.466 gram. We have a unit for the mass. Is that clear, guys? Look at one more question. It's a different type. I've seen this question in OCR past paper and AQA past paper. How to work out the volume of water added. The same solution, look at the same solution. We have one solution whose volume and conc is given to you. Like HCl is a solution whose volume is given to you and conc is given to you. You have to add some water, that I don't know, X amount of water added, so that its concentration changes to this value. Before you adding water, the concentration was 0.5 and the volume was 250. When you add water, the concentration decreases. Why? I will tell you. Look at the formula for this. Is called dilution question. So these questions, we call them as a dilution question. And how much amount of water you have to add to make this concentration or to decrease its concentration. So conc equals to a mole over volume. As long as my solution is same, I mean as long as one solute is there, we can use this formula. So when the solute is same, like my solute or my chemical substance is HCl, I'm not changing HCl. Look at that, HCl is same. When the solute is same, so what's the relationship between the concentration and volume? Inversely. Conc is inversely proportional to volume. What does it mean? It means that when you increase the volume, concentration decreases. It's inversely proportionality. With that, we are getting one equation, C1 V1 equals to C2 V2. Very important equation, guys. Very important chemical formula. You can use this chemical formula when you will get a titration question to figure out the volume of the water added or the volume of the solution added. See, both this relationship is inversely. When you are adding or diluting some solution, its concentration decreases. So we are using the same phenomenon. Okay, so if suppose I will take C1 V1 and C2, we have to work out V2 first. Work out the V2. So C1 equals to 0.5, agree. V1 equals to 250. Now C2, its concentration changes to 0.2. As I told you, when you add some water, its concentration changes because you are diluting the solution. It's so clear, it's so obvious. And V2 equals to how much? Okay, if you don't mind, can I rub this part, only that part? Okay, no, look at that. Use the same formula, C1 V1 equals to C2 V2. Okay, in some books it is given as M1 V1 equals to M2 V2 because the molarity and the concentration is same. A little bit difference, I don't want to go in that detail. So C1 V1 equals to C2 V2. How much is C1? C1 is 0.5 and V1 is 250. C2, I think C2 is given 0.2. C2 is 0.2. Look at 0.2, and we have to work out the V2. That's the final volume. This is the initial volume. Initial volume is 250, and the initial concentration is 0.5 mole dm minus 3. When you add X amount of water, the volume increases. So we have to work out the V2 first. V2 equals to, look at that, V2 equals to 0.5 times 250 divided by 0.2. So no point cancel. So V2 equals to 5 times 250 divided by 2. So 5 times 125. Agree? Yep. Now V2, just work out the V2, use your calculator. So 125 times 5. Look, 5 times 5, 25, 5 2s are 10, 11, 12. 5 1s are 5 plus 6, 6 2 5. So V2 equals to 625 centimeter cube. I want to work out the volume of the water added. This is not the volume of the water added. This is V2. We want to change to V2. Look at that picture. We have a volume which is 250 and the final volume it's 625. How can we work out the volume of the water added? So this much is the volume of the water added. Now please focus on this question. I've seen this question in the past paper of AQA and OCR. So volume of the water added, volume of H2O added equals to V2 minus V1. 625 minus 250. So work it out. How much is that? And I think it's easy. You can use your calculator and work it out. So whenever this type of question will be given to you in the examination, don't just end up your question after calculating V2. Volume of the water added is equals to, did you get it? Okay. It's 375. Is that okay? 375 centimeter cube per centimeter. Okay. Whenever you will get this type of question, please don't try to end up with the V2. They're not asking V2. Look at the question. Volume of water added or needed. That is V2 minus V1. So guys, I want to stop my lesson here. Please practice those type of questions. Check your past paper based on the concentration and the amount of substances. You can see your past paper of OCR and AQA. It doesn't matter. The content is same. So we will meet in my next lesson.